So some students really struggle with choosing a stats test, and it can be up to 6 or 8 marks in an exam. So I just wanted to recap choosing a stats test and how to know which stats test to use. Now, we've got the flowchart in the booklet. But if for whatever reason the flowchart doesn't make sense to you, this is the flowchart in a table form. So it's exactly the same information, it's exactly the same choices when deciding on a test, it's just in a table form. If the flowchart doesn't make sense, have a look at this and look at whether this makes sense instead. It's got the same tests, the same decisions, it's just in a different format. So remember, when you're choosing a stats test, you need to know whether you look for a difference or correlation, what design you're using, and what level of measurement you are using. So your design, so your independent groups is an unrelated design, and your repeated measures or matched pairs, well, that counts as related. Your level of measurement is nominal, ordinal, or interval. So nominal is categorical and it's discrete, so yes, no. Your ordinal data is something in an order. That's subjective. It's normally based on a questionnaire or a self-report. And your interval data is based on a numerical scale or a fixed scale that has equal units, so time and weight. A good example of interval data. If you are still struggling with telling the difference between the different types of data, it might be worth working through these examples to identify the levels of data. Apologies for the children typo. So you've got 4 examples here where you can decide whether it's nominal, ordinal, or interval data. And 4 more examples here. The answers are on the next page. Oh, the answers are not on the next page. So the levels of data. So number 1 is nominal data. Number 2 is ordinal data. Number 3 is interval data. Number 4 is ordinal data because it's based on a questionnaire. Number 5 is nominal data. Number 6 is ordinal data. Number 7 is interval data. And number 8 is ordinal data. Again, you've got that table. It's sometimes also worth looking at just random examples of hypotheses to decide what statistical test or what inferential test you would use. So you've got 4 examples here. And an example here. These are the tests that you would use for those examples. So chi-squared, Spearman's, unrelated t, Wilcoxon or related t. It depends how you measure your data, and unrelated t. Remember, with statistical tests, you've got non-parametric and parametric tests. Parametric tests have interval data. They have data without a skew, so from a normal distribution, and they have data with a normal sample. Now, it's also worth thinking as to how your levels of measurement link to your averages and your spreads. So levels of measurement is your ordinal, nominal, interval. Your measures of central tendencies, your fancy word for averages, so your mean, your median, and your mode. And your measures of dispersion are measures of spreads. Now, there is a better average and a better spread to use for the different types of data, and that's shown in this table. And it's worth having a look at this because sometimes you can be asked a question, why would, for example, a mean be a better measure of central tendency in this experiment? And you could just put as an answer because the experiment produces interval data. So that's why mean is better. So you've got for nominal data, mode is your best average. There's no dispersion in nominal data because it's discrete. For ordinal data, your best average is median. Your best measure of dispersion is a range. For interval data, it's a mean and standard deviation. When we've looked at an inferential test, we are sometimes asked whether that result is significant or not. It tells you at the bottom of the table on your exam paper whether the observed value needs to be higher or lower than the critical value. So the observed value or the calculated value needs to be higher or lower than the critical value to be significant. It tells you this on the exam paper. However, if you want something to learn to save you having to look for it on the exam paper, there is kind of a trick. If the stats test has an R in it, so Spearman's, Pearson's, chi-squared, unrelated or related t-test, then the observed or the calculated value needs to be greater than the critical value. So the tests with an R in them, the observed value is greater than the critical to be significant. And the tests with a W in them, Mann-Whitney and Wilcoxon, and also sign test, because it doesn't apply to the rule another way, the calculated or observed value needs to be lower than the critical value. So this will be in the exam under the table, but if you want to have kind of a shortcut so you're confident, the test with the R in them, the observed value has to be greater to be significant. The test with the W in them and the sign test, the observed value has to be lower to be significant. The rest of the presentation talks you through the different statistical tests and gives you some examples of how they might be worked out. Remember, you'll never have to calculate a value of a test in an exam apart from a sign test, but for some people it helps make more sense. T-tests, an example of a parametric test, so just a reminder of when you would use a parametric test. T-tests also look at degrees of freedom, so they don't look at an n value. With an unrelated t-test, your degree of freedom is your sample size, take away 2. With a related test, related t-test, your degree of freedom is your sample size, take away 1. An unrelated t-test is where you have interval data and independent groups, and remember that observed or calculated value must be greater than the critical value. This is an example if you want to work through it. So that's an experiment. Those are the results. This is how the test is worked out. So it's the total of the score squared. That gives you a t-value of 0.87. So you to work out whether that is significant, you work out your degrees of freedom. You look in the table for the critical value, and then you decide whether you're going to accept your hypothesis. So you would have to do this bit in an exam. So your degrees of freedom in this case is 14. Is it a 1 or 2-tailed test, or it's in the stem before? Go back and check. It's a 1-tailed test. Your critical value for a 1-tailed test at 5% with a degree of freedom of 14 is 1.761. So you've got an observed value, you've got a degree of freedom, you've got your critical value. Therefore, your results are not significant, as 0.87 is lower than 1.761. So therefore, you should accept the null hypothesis. Related t-test is interval data. It's repeated measures design. It's a test of difference. So again, just another example. So if you've got 10 participants that have their heart rate measured before and after CBT, and your hypothesis is there'll be a reduction in heart rate activity. In an exam, I would always, if you've got a hypothesis, just write next to it whether it's 1-tailed or 2-tailed, because later on, if it asks you to work out whether the results are significant, you've already done that work. So your t-value here is 1.386, so that's your observed or calculated value. You've got 10 participants, so your degree of freedom is 10, take away 1. So that's 9. It's a 1 or 2-tailed test. It asks for a reduction. So it's a 1-tailed test. Your critical value, so you've got a 1-tailed test at 0.05. You go down to a degree of freedom of 9. So your critical value is 1.833. Are your results significant? So you've got your t-value, so your observed or calculated value is 1.386. The critical is 1.833. Your results are not significant, so you accept the null hypothesis, and that is your conclusion. Mann-Whitney and Wilcoxon are your tests of difference for ordinal data. So Mann-Whitney is difference, ordinal, independent groups. Again, there's just some examples. That's how it's worked out. You'll never have to do that in an exam, just for maths people. And it gives you a result. So in this case, your calculated or observed value is 2. So what you have to do in this test, you've got 2 n's because you've got 2 groups. You have to work out what your n's are and then find out what your critical value is. And that is how you will write your conclusion up. The critical value table for this test looks slightly different because you've got two n values. You have to kind of look down and then look across to work out your results. Wilcoxon test is repeated measures with ordinal data and a difference. Again, you wouldn't have to work this out in an exam, but this is how the data is worked. So in this case, your observed value is 8.5. You compare your observed value to your critical value. So in the same way as before. And then use the table to work out whether that is significant or not. So you've got a one-tailed test. It's 0.05 and your n value for this is 7. So you've got 3 as your critical value. Your observed value is 8.5, your critical value is 3. With the Wilcoxon test, your observed value needs to be lower because it's got W in it. That's not lower, so it's not significant. That's how you would write that up in an exam. Here are some examples. You can look at the critical value tables in your textbook and you could work out whether these results are significant or not. Chi-square test is done on nominal data. It's a difference, it's an unrelated design. You tend never to see it in an exam as a correlation, so just ignore the correlation bit there. It's a difference and unrelated design. Chi-squared also used degrees of freedom. So this experiment is more 8-year-olds and 5-year-olds are able to select a card that represents a different perspective than their own. The calculated value is 23.1. That's a one-tailed test. Your degree of freedom is the row total take 1 times the column total take 1. So that's 1. And then you look up the critical value. So you've got a one-tailed test. Your degree of freedom is 1. So your critical value is 2.71. Your calculated value was 23.1. So in this case, you're significant and you can accept the results. That is Russ's research that we looked at before in content analysis. This is an exam question that was based on that. The sign test is the only test that you'd have to calculate a value in an exam. So it is also on nominal data. It's used on test of difference, nominal data, and related information. You may have to calculate an observed value in an exam, and then you may have to say whether that is significant or not. So this is just a reminder of how you use a critical value table. Okay, this is an example in the book. This is how you would work it out. So the 7 students were better, 5 students were worse, 3 were the same. So for a sign test, we always take the least frequent sign. So in this case, it is 5, because 5 is a smaller number than 7. We've started off with 15 participants, but 3 didn't have a difference. So we've got an N of 12. So we look on a critical value table. So we've got an N of 12, and we have an observed value of 5. So that's the critical value table. So we decide whether we're 1 or 2-tailed. This is 1-tailed here. We use our N of 12. You have a critical value of 2. We had an observed value of 5. And then you can say that that is not significant because our observed value is higher than the critical value. When you look at a correlation, you'll use either a Spearman's or a Pearson's test. A Pearson's test is your parametric test, so for your interval data. It's worked out in exactly the same way, so there's another example if you want to try and work it out. That's how you would write up the answer. Spearman's is on ordinal data. Again, you wouldn't have to do this math in the exam. it would give you the observed value, which in this case is 0.867. The plus shows you it's a positive correlation. If it was a minus, it'd be a negative correlation. Sorry, that's your n value and your observed value. You can use the table to work out whether that's significant. So you've got one-tailed test, 0.05 is 10. So your observed value is plus 0.867. Your critical value is plus 0.564. For Spearman's, your observed needs to be greater than your critical to be significant. It is. So this is significant, and that's how you would write it up. This is how some of the exam questions look on choosing a stats test. It's the kind of thing you would have to do in the exam.